That's where the new paradigm is headed. So see, such is the impact of what machine learning will have as you graduate into the workforce. The key to learning machine learning by doing it is twofold. One is, let's reduce the barrier of entry so that you don't have to be a statistician, an expert at deep learning framework, and then say, okay, whew, now that we know all this, we've taken OpenCourseWare, we understand, let's see if we can start to do this Python and R and Becca. It's just exhausting. Should be a way to get you started without knowing every little bit and byte. But at the same time, and this is very important, for the curious-minded, which I know you guys are, if machine walked you through machine learning and you are seeing how it's doing what it's doing, you should have the right to challenge the machine and say, why did you do that? Why did you take my data and remove the outliers at this step? Why statistical outliers? Why did you do that? And the machine should be this is the key, should be very transparent and say, okay, well, here's what I found in your data. Here's the theory and statistics that says why I should do what I did. So this is what I did. Do you want to overrule me? And you look at it and say, well, okay, I get it, but maybe not the entire thing. You can click more help, get even more help. That is how you learn machine learning truly, by observing how an intelligent machine is using the ML platform to construct itself. Hope that made sense.
Yeah, so EazyML is, most of the platforms that are out there today are really black boxes. They don't tell, how they reached, the predictions. EazyML is very, very transparent. So I guess we are encouraging you to learn. You can get started right away with EazyML, but once you've tried it, you have the context, you can dig deeper and learn theory and, algorithms that power it. And that way, you've already tried the platform, it's probably going to make more sense to you. You learn faster and it'll be more fun learning. So without further ado, I guess machine learning is really, it consists of just 3 steps. It's a 3-step process. The first step is really the data set. The first step is really defining a problem. What is the problem? What is the use case? What is it that you are really trying to solve? Once you have defined a problem, once you have a use case, then you come to the data set, preparing the data set.
So here are various types of problems you could have. You could have, well, I'm doing an experiment in which I want to see if while the music is playing in the background, does that mean that I get more of my ping pong shots in on the table versus when it's not, right? A simple t-test, for instance. That's a problem. That's a use case. And here's another one. How do the various factors lead to deterioration of vitamin C in an orange? The sunlight, the temperature, the the humidity, etc. How do these things lead to deterioration of vitamin C? Okay, I did a lab experiment. Now I want an intelligent machine to learn from the data in the experiment and be able to predict for me. Here's another one. Which university should I apply to? Given this is my SAT, ACT, these are my grades, these are the recommendations I got. Which university should I apply to so I don't waste a whole lot of money applying to a bunch of universities that wouldn't give me admission? Well, interesting idea for an app that you can develop. Here's another one. When I drink coffee in the morning, do I get fidgety and type faster versus when I don't? Is it decaffeinated? Is it caffeinated? Does it matter the brand? Folgers versus whatever else, Nescafe, etc., or Starbucks. How many cups I had, and here's the typing speed. Tons of such lit data and use cases and their respective data littered all around you. Here's a big one. So my dad has suffered from hypertension, all right? I want to be able to tell as to what in his day's activities causes a reduction in hypertension versus an elevation in hypertension. Very useful use case. Well, so I'll record stuff in an Excel spreadsheet, right? This is when he woke up. This is the stress hours at work. This is what he ate. This is the amount of time he exercised. A whole bunch of things that he did. And at the end of the day, here is the systolic and diastolic pressure. And you have 78 such readings that you made over 3 months. Now you can actually have the machine predict your dad's systolic, diastolic reading, given how his day is going about, and be able to, and this is the beauty, offer you insights. These things matter because each person is their own person. These things matter when determining the blood pressure of your dad. So if he exercises for more than 20 minutes, then we see that most throughout the day, his blood pressure is controlled. If he takes the following dosage, then we see his blood pressure is under check. If he is putting in, having a hectic day with stress, then we see there is a spike. Right after food, and if these types of food, then we see a spike. So on and so forth. Just imagine the power of such apps and use cases that you can develop.
Right. So going back to machine learning, the 3 steps. Once you define the problem, you prepare your data, you format, clean, transform, make it ready for consumption into EazyML, and then you build the models and predict. As simple as that. Define your problem, prepare your data, build the model, and predict. Just 3 simple steps. So EazyML is an automated platform. So, it keeps the algorithms, codes, etc. hidden. It automates the data cleaning and model building exercise. And, really, machine learning is as much as an art as it is a, statistical modeling discipline. So EazyML has inbuilt intelligence in it, where it makes decisions. It has default values, and all you have to do is just accept it. Or if you want, you can also play with the machine and not accept the default values and see how the machine, the predictions are influenced by the changes that you make. So here, this slide again, this whole process is automated in the platform. And then here again, this talks about if you have, let's say, a business or any kind of a problem, or if you're building an app, you come up with the problem statement, you understand the data, you prepare the data, and then EazyML is going to help you prepare cleanse the data, do the modeling, evaluate, and then you can deploy or predict. And then the process continues. It's an iterative process. Like Deepak said, these days, probably you're seeing with COVID-19, the models that they have, they were predicting, unfortunately, mortality rates, really a lot, which has changed since yesterday because their models changed, because the data changed. So it's a continuous process. It's an iterative process. As the data changes, so the model changes, so the prediction changes. So we are going to start with I wanted to show you your Slack channel. This is the website, by the way, I was able to show in the beginning. You guys can go and you can go to personal, and the data repository is here. And once you become comfortable with the GUI version of the platform, we also have the developer version of the platform. And for going to the portal, this is the web address. This is the URL, tryEazyML.datanomers.com. And then we also have, we will be sharing with you guys a Google spreadsheet with a lot of information, a lot of links towards data sets, beginner level, intermediate level, advanced level, and just a lot of content to help you guys learn machine learning. And all this will be here. So the Google spreadsheet is going to be here, and then all of you are going to get an invite to join this Slack channel so that you can communicate with us and communicate with each other here. All right, so this is the portal. I hope that most of you or all of you are able to log in, and you guys can just follow whatever I'm doing. And as I said, I'm going to pace myself so that you guys can follow me. If for some reason, somebody is not able to, just watch. And then we are recording it. We are going to put the recording on the Slack channel.
They can always ask.
Yeah.
Is everyone logged in? I want to check. People log in.
Yeah, maybe Jason is looking at it. Okay. Oh, before we go, I wanted to show you how raw data looks like. So the use case that we are going to show you guys today is predicting your ACT score. So a lot of you are taking, SATs and ACTs. We got this data from one of the companies, a tutoring company that has ACT students, and they gave us their data. They want to predict the score of ACT for their students.
Of course, it's anonymized.
Yeah.
So no privacy has been compromised here.
Yeah, there's nothing. The entire data is anonymized. So this is how the raw data looks like. And you guys can also build something like this. Like, if you guys get together and you are willing to share your make a Google spreadsheet and just put your data, your SAT score, it could be anonymized, and, put other variables as well. And it will help you learn how the machine really predicts and what are the variables that are influencing the prediction. So I'll just go over this real quickly. This is the timestamp for when these students took the baseline, the diagnostic test. These are the name of the towns where the students were from that enrolled in this tutoring company. The state, another question they asked was, did they finish their diagnostic test on time? The next column is, which section did the students ran out of time? What school year they are in? What is their GPA? How many times did they take the real ACT test? And then there are a bunch of questions that they use to determine the attitude of the students, their learning, like do they think that human intelligence can't be changed very much? Do they think it can be changed significantly? Just to evaluate their attitude, in general, to see if it really influences the predictions. And then, another variable is coaching. Did they take any coaching? How many hours did they prep for the ACT test? And then what is their baseline English score, baseline math, baseline science, reading, and so on and so forth. And then this was their ACT score. Remember, this is the training data, right? So you're training the machine. So you have to give all the variables. You have to also give the outcome.
Yeah. So what you see here is classic training data. In this case, in a spreadsheet, you've got a whole bunch of predictors on the left, which contain all kinds of information about a student, right? Their baseline scores, which school year they are in, what's their attitude like, and so on and so forth. And then, so those are called the predictors because it's going to help the machine to predict. And the stuff in column AF is called the outcome because that's what the machine is going to predict based on the input predictors. The predictors are input to the machine, and then the trained machine uses those predictors to predict the output outcome, which is your ACT score. Just some basic terminology for ML.
Yeah, and then in the test data, this column will not be there, right? Because you're trying to predict the ACT score.
So the machine's trained now, so it says, okay, this is your training data. It says you've told me what these scores ought to be based on these inputs. I get it. I'm trained. Now, when you specify further data to me, you don't need to include column AF, ACT score. I know. I will predict it for you. You can keep that blank. And that's why you trained me for it.
So this is how the training data looks like. All right. So I'm going to start.
Any questions, comments, observations?
Anybody have their hands on? No? Okay. So we are going to, so remember, what we are trying to predict is ACT score of students. So we are going to go in the detailed mode. So just to give you an overview of the platform, right? You see these buttons as we are going to use them, and I'll explain them as we move along. But one of the most important buttons is this one. This is the help button. Anytime you have any question, you just click and it's going to explain to you what it is. So for example, this is the first page, right? You see accelerated mode, detailed mode, and you're thinking, what is this? You go here and it explains to you. Accelerated mode means EazyML is gonna just run through various steps without stopping for your input, you know? And detailed mode means EazyML goes through steps and it stops for your input so that each step you can tell EazyML what it should do.
So this is perhaps the most important button, that question mark, because remember our intention here is to learn machine learning. And you see the machine doing its stuff, but there are obviously questions in the curious mind saying, why did it do that? Why? Hit that button at every step. It's going to tell you why it's doing what it's doing to your data. And so in the process, you will come away that much more appreciative of ML.
Yeah, it's a very helpful learning tool. And then on the left side, you see this menu, right? This has information about your account. If you upload training data set, however many you upload, this is going to keep an accounting of all the training data sets that you've uploaded. And then how many models you've built, it's going to keep an accounting of all of that. You can delete it, but everything is here. And then it has all the other information, prediction data set, usage, you know, how much you've used, all your activity is recorded here. So for example, you guys have we gave you the standard, all of you who signed up have access to the standard subscription tier, and all you have access to 1,000 rows and I think it's more than 20 columns. So you guys can just start using it right away, the platform. So we are going to get started on our prediction. We'll go with detailed mode so you guys can see. The first thing it's asking is to upload our training data. What do we remember? We have to upload the training data, we have to build the model, and then predict. Those are the 3 steps. So it's asking us to upload the training data. We say yes. Upload the file from your device or Google Drive. We're going to say device. Okay, and now it's asking us to upload the file. So it's the same file that I just showed you guys. Okay, so we are going to upload this training data. Okay, so I already had a data set. I'm going to say yes, replace the existing data set. All right, so it says your data has 101 records and 33 variables. And it gives basically a snapshot of everything. It has uploaded all the columns and all the rows that I showed you in the raw data. You can see everything is here. All these variables about attitude and everything. Okay, so we go next. Please specify the identifier variable in your data. So we don't have an identifier variable. We didn't, we anonymized the data. There is no ID, there's no name of the student. So we are going to say none.
Usually the default recommendations are spot on. The machine has analyzed, used statistical judgment to make those recommendations for you based on your data. So if you just keep hitting next, 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 you will be on sound footing.
Yeah.
But that doesn't mean you shouldn't challenge the machine. Hit the question mark, see what it says. You may not feel convinced, in which case feel free to do something different. And you can always hit your trace button to see what you did, so that next time around you say, that's what I did last time. So maybe this time I should do differently. Here's the trace button. You want to show that.
Yeah, so here's the trace button. So far you've done you've only uploaded the data.
So whatever you've done,
yeah,
in a given session, it may be that you have gone through your training data 7 times, each time a little differently, and you still aren't convinced that you got the right ML model for prediction. And so you can go back and look and say, this is what I did last time, and that maybe I need to change this, and now it will be good. So it's giving you all the information about what you need to do or what you've done in the past. Why am I telling you should do this? So that you're learning in the process.
Right. So now we are still in the process of, getting the data, sanitizing the data. It's asking, please select the columns that you want to discard. So I think that I'm going to discard the timestamp. It doesn't really matter what time you take the test. It's what city you are in or what state you are in. So I'm going to discard those 3 from my prediction set. And I think I'm going to also discard the ACT boost, because boost basically means like, by how many points was your score boosted? So I'm going to, we are predicting the ACT score, so we don't really want to know the boost, because it's basically the same thing.
So here's the thing about machine learning. The machine learning platform is truly intelligent. It can analyze all your data, throw in all the data you got, the kitchen sink and then some, and it will be able to weed out stuff that it thinks are frivolous predictors, right? Predictors, that terminology, the input variables to a prediction model. It just says, these are frivolous, I'm going to throw them out. Well, these matter, so I'm going to keep them. These predictors I'm going to keep and use them for making predictions. For purposes of fitting stuff in an hour and expediting, we've removed some which we already know are frivolous. But even if you didn't remove them, the machine would have said that those city and time don't really influence your ACT score, and so I'm going to remove them. So the machine learning platform is truly statistically intelligent in the sense that it lets the data in your training data, it lets the data tell the story, not subjective biases.
So now it's saying that EazyML has inferred the data types, and do we want to change the data type? So we do have the ability to change if we wanted to, but we are not going to. So there, you can see finished ACT on time. It's a categorical data type. Which section you ran out of time? Categorical. What is your GPA? It's numeric. So everything is good.
And so you're wondering what the hell is categorical? Hit the question mark and hit more help if you want to know more details.
Yeah.
So it says categorical is what it says. It's a category. The category is the weather. Is it sunny? Is it cloudy? Right? That's a binary categorical variable. type of car you drive. That's a categorical variable. Subcompact, compact, sedan, and luxury. 4 different categories now, right? Still a categorical. Versus a numeric is a continuous. Your ACT score, 31, 26, 35, 22, 17, hopefully not, 33, all over the place, right? That's a numeric, but it's all explained. So don't say, well, what the heck is category? Just take a look, and you will be well advised by the machine and trained.
Yeah. So we are going to take the default value, and we are going to move. Okay. So now EazyML has derived the mean, median, standard deviation from the data. Okay. We keep moving. Do you want EazyML to impute the missing value? Yes, we do. So remember when I showed you the data, there were certain fields that were missing. And what EazyML is saying, so let me show you. So for example, here, the GPA is missing, right? There are many missing values. So EazyML kind of imputes those values because you can't have a missing value in the data set.
So while you were filling in the training data for your dad's routine, that particular day, you forgot to note if he exercised for more than half hour or less than half hour. So that's a blank value. And so you forgot to put in for numeric data like how much food did he eat? Maybe you measure that. So machine will try and make educated guesses. Obviously, it would have preferred if you had recorded that, but the fact that you haven't doesn't mean now you have to just completely throw away that particular record. It will still make effort on your behalf to intelligently auto-populate what it thinks you should have populated there based on some statistical theory. Okay.
So there you go. It's all the imputed values are in blue. So it has imputed the values, and now the data is all good to go. So let's see. Now the next step is it wants to remove the outliers. So do you know what outliers are? They're the extreme values that deviate from the rest of the data.
So you can press more help. Now, suppose you had one record that said temperature in Cold Neck, New Jersey, and the value was 305 degrees Fahrenheit. Obviously, that's an outlier. The machine says that doesn't look and smell right. Given where the other values are, 28, maybe all the way up to 90, 303 degrees Fahrenheit just seems like it's way out there. And so that's what outlier means, way out there. And so it removes it. Why does it remove it? Because otherwise you would be misleading the machine during its training. Yeah, it's like a teacher who's not, after all, training data is the machine's teacher. It's like a teacher who got up in the class and fed you some wrong information. That would be disastrous, right? So that's why it automatically removes things that it knows you may not be teaching it right.
So we are going to say yes, we do want to remove the outliers. There are no outliers present in the training data that was uploaded, hence no records were removed, okay? So let's keep going. The following data points will be used for building models. Now it's all cleansed the data, sanitized it, and it's showing you all the variables that it's going to use to make the model. It's the process data. So we say next. Now it's asking, what is it that you want to predict? We've cleaned the data, sanitized the data, it's ready now. Tell me what you want to predict. So what is it that we want to predict? We want to predict the ACT score. Given all the variables, what would be the ACT scores of the students? That's what we are trying to predict. So we are going to choose that, and we'll say next. So now it's just telling how many rows of data was, what are the number of native predictors. So native predictors are basically the variables that are in your raw data. They were 28. and the selected outcome variable is ACT score. That's what we're trying to predict. So we go next. This is just to visualize. If you want to plot, visualize, we're going to skip that in the interest of time. So the first step is now completed. Your data is ready. It's cleansed, sanitized, ready. Now the machine is going to build the model. First step completed. Now it's asking, do you want to continue with building the model? And we say yes.
This is the true machine learning now. It's going to use that sanitized training data to train itself.
Yes.
And become intelligent about your world so that it can predict your world.
So we are trying to predict, so we are going to use the predictive model, problem type regression, outcome variable numeric. Do you want EazyML to remove dependent predictors? We are going to just accept the default value. So remember, EazyML is an automated platform. It has these built-in guideposts and sanity checks. It's very smart machine, so you can just take the default recommendations, and we'll say next. Do you want EazyML to derive new predictors from numeric predictors? Again, the EazyML is saying no, so we are going to take the default. We're going to say next. EazyML will select important predictors from the list of predictors. So now it's in the stage of feature selection. So we'll see. It has identified all the predictors which influence the outcome that you're trying to predict. Okay, so it's done its feature selection. Okay, so now it's building the model. EazyML will build models on your data. It's just showing all the data that we have, and it's going to build the models now. It's building models. And it's going to build several models, and then it's going to recommend one of the best that it thinks for the prediction. So there you go. It has built, I think, 7 or 8 models, and it's saying that boosted decision tree is the model that it recommends. So we are going to take that model to make our prediction.
So all these are statistical models, by the way, different types of statistical models. And the one that won the race for predicting your world is the boosted decision tree.
So we're going to take the recommendation of EazyML. Now here it shows, the graph shows the global importance of the predictors. So what did EazyML, what variable did EazyML consider the most important in predicting ACT score? So the #1 variable was the baseline composite score. The #2 variable that EazyML thinks is the most important for predicting ACT score is the prep time. Those two are the top predictors EazyML thinks to predict the ACT score. So let's keep moving. Now the model is built. It says model is built. Now we are at the stage where we are going to upload the test data to really make the predictions. So do you want to continue with using the built model to predict your data? Yes. Please select the model. So you saw that boosted decision tree is the one that EazyML recommends. So we are going to take the default recommendation. Upload data for prediction in your file, in a file. So we are going to upload now the test data. You can upload it from your device, from your laptop, or you can upload it from Google Drive. If you upload it from Google Drive, it's going to ask you to give permission to your Google Drive. We don't see anything on your Google Drive except for the whatever you upload, the data that you upload. So we are going to say yes. And this is the test data. So we are going to upload the test data. Okay, so prediction is ready. Let's see now what the prediction is. Click next to see your predictions. Okay, so these are the predictions. We have predicted, if we scroll to the right, what were we trying to predict? What is going to be the ACT score, the predicted ACT score, right? So these are the baseline scores, and these are the predictions EazyML made. So for example, let's say this one. The composite score was 28, and EazyML predicted that this student will have almost a 4-point jump, 31.97, right? This student had 33 baseline score, and 33 is his or her predicted score. This one, again, 4-point jump, 20 composite baseline score, and EazyML predicted. It's, you know, this student is going to have a 24, about a 24 ACT score. So let's find out.
The first student had nothing, no increment due to the tutorial.
Yeah,
huh?
yeah,
Okay.
yeah.
Okay,
So let's just take one of them. We're going to see how EazyML has predicted and why it has predicted the way. Do you want to understand why EazyML predicted the way it did?
So this is the very important step. Remember, we said you want to, your dad wants to understand as to why is it that sometimes his blood pressure is higher versus lower. This is what will tell you. I want to know, why did the machine predict that his blood pressure is going to be low today? Because if I know the reasons, then I'll tell him, Dad, you need to do this every day, because the machine is saying, I've checked it 4 times on 4 different days of predictions, that this is the reason why I think the blood pressure is going to be low today. And it truly was low. So you need to do more of this activity. So very important step.
Yeah.
This is perhaps in literature, you will hear of this step being called explainable AI. That's the terminology people use in the machine learning paradigms. But the key is that the key to this is that there is a fine distinction there, but I'll not go into it. But this is the only comment I'll make is this is for a particular prediction, right? Versus, remember, the earlier prep time that was important and was for the entire training data. Hopefully that subtle distinction makes sense. Ask away. If there are any questions, ask away. So this is telling you exactly why the machine made its predictions. It's very transparently telling you why I predicted the way I did.
Yeah, if you have any questions, please post it on chat, and we're going to answer it. So let's take a look at this one. The baseline score was 20, and EazyML predicted it's going to be 24, a little over 24. So we're going to click choose, and remember, nothing is 100%. You know, it's as good as your data is, the predictions are going to be as good as your data is. So here, baseline composite score was 20, and prep time was 27 hours, and then baseline math score was 24, GPA was 3.5. So the most important variable in predicting the score was the composite score and the prep time. Those two were the most important, and the third was the baseline math score and then the GPA. And if we go to find out another one, let's take one more and find out, like, for example, this one almost had a 4-point jump. So let's see, this student had the baseline composite score of 28, and then, wow, he or she
really slogged it out. Huh?
Prepped for almost 100 hours. So the most important predictor, you know, for this student was the baseline composite score, and then the second one was the prep time. Okay? So you can understand what the machine predicted and why it predicted the way it predicted. You just go to, you can also trace your steps. You go to trace, and you can see everything that you did so far. If you want to go back and change something, because you just feel like, you know what, I don't think this variable is important. I want to remove this variable, or I want to see what variables did I remove. I can go all the way back and see what all I chose and what all I discarded, and start over. So and then this button is just to go back home, start over.
Any questions? Please feel free to ask.
Any questions, guys?
Don't hesitate.
So I also wanted to show, okay, so the data repository I showed you guys. There is a video, there is content on the website. So there are two different ways to access content. So you guys are going to choose the personal website. And on the personal website, there are a few tutorials. And on the, I guess, for the enterprise website, also there are tutorials, but I would recommend go to the personal and just check out the tutorials. And in the tutorials, it has why do ML, why EasyML has made machine learning easy, and then a bunch of other, videos. And then go to the dataset repository and try out the ACT one that we just did. You have the training data as well as the test data. This is the Titanic, this is the description. All these data sets you guys can try on. And we are going to continue to post more data sets and more content on our website so that, it's easy for our EasyML users to find information. Any questions?
I know a big challenge in the past was training data. So that's what Meeta said. She'd continue to post. But you guys can get creative too. Create your own Excel spreadsheet, make records. You do tons of lab work. So you generate training data by the droves.
Yeah, I think we should talk about how they could use their,
So you can generate training data by the droves, and just in the space around you that you live in and function in, right? There is every day if you record something about yourself, about your family, with a view to predict something, right? Like we went through several use cases in the beginning. Just make those part of your Excel spreadsheet. You're a very disciplined group here.
Yeah.
You just continue to add that every hour, every day, every week, whatever, and soon you have your own training data for stuff that you'd like to be able to predict.
Yeah. So let me give you guys an idea. Maybe you guys could, after you have tried the data sets that we have provided, maybe one project for you guys could be you just have a shared Google Drive and everybody should come up with your own variables on how you can predict SAT scores, or how you can predict, which college is going to accept you. What are the variables that influence it? Again, remember it's the predictions are not going to be 100% accurate. See what's going on with the COVID-19 predictions, right? It's an iterative process. And
yeah, I must emphasize that word, iterative refinement, because there are two things about training data. One, it's not complete at times, meaning you could have a particular variable that if you had that values for that variable in your spreadsheet, your machine would be that much more better at predicting. It was an important variable, important predictor as we call it, but you didn't stumble upon it, it didn't strike to you, or there was no way to make those recording observations for that variable. So it wasn't there. Incomplete data, training data, right? Holes we talked about, right? You forgot to make an observation for a given day on a particular record. Well, you have a hole there. Those are the things. Then there are something that is so prevalent. It's called biases in your training data. So you are making observations as to the days a SLA service from New York to DC runs on time, for instance, right? And so you're seeing most of the days it's 10 minutes late. And then towards the end of the month, when you're making first 20 records usually have late, 10 minutes. And the last 7 days, it starts to be on time. Just a quirk of fate. Not that anything changed in operation of SLA service between New York and DC. but that's a bias. You can't really blame the machine for saying, well, it depends whether you are asking me to predict before the 20th or after the 20th, because after the 20th, it runs on time, just because your training data had a bias like that. So all these things, holes, missing variables, biases, are living proofs of where machine learning can, I wouldn't say misfire, but machine learning is not as accurate as it could be, right? The COVID predictions, for instance, why is it that they made predictions and then they're continually refining it? Because they are missing some of the variables in there. Perhaps the fine-grained variables, right, on how the doctors are treating patients. Maybe HCQ, hydroxychloroquine, has had an impact, and that wasn't factored in, right? Missing data, incomplete data. Maybe there are biases in that data. Whoops, so you got to refine it now that you know that machine made this prediction, but that's not really true, and so I got to continually refine it. So beware of these things. We all live in a real world, not in an ideal world, right?
Yeah.
So we got to live with these.
Yeah, nothing is 100%. So I know we are almost at the top of the hour. I wanted to say a couple of things, in conclusion. If there is one takeaway from this workshop that we would like you guys to take away from, it would be that, EazyML has made it really easy to learn machine learning. It teaches you learn machine learning by doing it. It's a platform that you have access to. Take advantage of it. And the other thing I wanted to say was, we organize, competitions and contests sometimes. And if you guys are interested, let me know. We can organize one for your group where we can come up with training data, or we can come up with use cases. We can collaborate. That's something that we are very willing to help you guys with so that you can learn. And last but not the least, the female students at High Tech High, I would love to help you guys in any way I can. If there is any other information you need, I'm very passionate about, helping women who want to really make an impact in technology. So please reach out to me. I know some of you have already. You have my email. I'm available via email as well as on Slack channel, and would love to help you in any way I can. So,
any questions?
Yes. All right. Well, thank you so much. Good luck learning machine learning. Everybody will receive their Slack channel. I know 7 or 8 of you have already joined it. Everybody's going to receive it by today, and everybody's going to also receive. Just let us know if anybody is not able to log in. If you have any questions, also let us know, and we'll also give you access to the Google Drive, where we have a lot of resources, and we'll continue to add more resources. Thank you so much. Yeah, thank you, Mr. Roche. Thank you so much for organizing this. Appreciate it very much. Okay. Okay, bye-bye, guys.